my name is Muhammad AMIRUSSOFIY, holding the matricard number D42007924924, and today I'll be talking about aircraft weight. So, MTOW, or maximum takeoff weight, is a structural limitation that was set by the manufacturer of an aircraft, and it was proven by the aviator authorities. During takeoff, if the MTOW is heavier than the specified, it will cause problems during takeoff. During landing, there are two types of landing, which is firm landing and heavy landing. So, firm landing, if the aircraft follows the MLW, which is maximum landing weight, it will allow the aircraft to apply the ground spoilers more quickly, and the wheels to spin up and the brakes to be applied. And on the other hand, a hard or heavy landing occurs when an aircraft hits the ground with a greater vertical speed and force than there is in a normal landing. For example, an HAR-72-500 has the maximum takeoff weight of 22,500 kilograms. Therefore, the flight dispatcher has to somehow load the aircraft within the specified weight to avoid any takeoff problems. But if you are unsure about what is your aircraft's MTOW, you can check on websites such as Skyberry or the documentation that was given to you with the aircraft. That's all.
Hi, my name is Nishan and I'm going to explain air density. The air pressure at sea level is called QNH and it's used to calculate the pressure altitude of the airport. A change in air pressure 1 hectopascal changes the pressure altitude by about 30 feet. A high temperature reduces the density of the air and the engine, and the propeller gets less air to work with, resulting in less thrust. A change in the air temperature of 1 degree Celsius changes the density altitude with about 120 feet. Here are 3 examples. At sea level on a standard day, the temperature is plus 15 degrees Celsius and the density altitude is 0 feet. When the temperature is minus 5 degrees, the density altitude is minus 2,480 feet, which means that air molecules are packed densely together like the blue dots on the square to the left. When the temperature is plus 32 degrees, the density altitude is 1,945 feet, which means that the air molecules are less densely packed like the red dots in the square to the right.
My name is ROKKEAN, or also known as Sky. I'm holding metric number D-Form 2007950. So now I'm going to present another factor that affects takeoff performance, which is wind. So the effect of wind is on takeoff distance is very large and important, and proper consideration must also be provided when predicting the takeoff distance. So there are two types of wind that affects takeoff performance, which are first headwind and second tailwind. So first I'm going to talk about headwind. So headwind is basically the wind that blows in the opposite direction of the aircraft movement, while on the other hand, which is tailwind, it blows in the parallel direction of the aircraft movement. So the effect of headwind is to allow the aircraft to take off at a lower ground speed, and on the other hand, tailwind requires the aircraft to take off in a much greater distance, which also means that requires the aircraft to achieve a greater ground speed to attain the liftoff speed to take off. So headwind, there is 10% of the takeoff airspeed will decrease the takeoff distance approximately 19%. And for tailwind there is 10% of the takeoff airspeed increases the takeoff distance approximately by 21%. In the case where the headwind is 50% of the takeoff airspeed, it will reduce the takeoff distance by approximately 75%. So that is all for me for wind. Now I'm going to pass it to the next presenter.
Assalamualaikum, I'm HAZIQ and I'm holding the ticket number P-Form 2007930. So I'm the fourth presenter in this group and I will explaining about runway condition. So the runway condition can be dry, wet and or contaminated, which means that the runway is covered by more than 3 millimeters water, snow or ice. So the effect ability to accelerate and stop, a dry runway is always the best one. So runway slow and appear reduce the acceleration but make it easier to stop. Example, a downhill good for acceleration for that make it harder to stop. And by all in all, downhill requires a shorter runway and is therefore preferred. I think that's all for me and what's the next
Assalamualaikum warahmatullahi wabarakatuh. My name is MAZLAN and I'm holding matric at P-Form 2007948. So I will be the last presenter for my group. So I'm going to discuss about aircraft configuration. So there's two types of aircraft configuration. So it is one flight setting and second airframe contamination. So for the flight setting, most airlines have an option to take off of the different flight setting. So a small flight setting, a takeoff requires along the runway, but give a better rate of climb. But for the larger flight setting require a shortest runway, but the rate of the climb is reduced. On the other hand, ATR aircraft, however, has the only one setting for takeoff, and that is flight 15. So we moving on for the aircraft airframe contamination. In addition, if the airframe is contaminated by the frost, ice or snow, during takeoff, aircraft performance will be reduced and the takeoff distance will be increased. So for my conclusion, our group conclusion, I think pilot must be familiar with the aircraft performance in accordance with Civil Aviation Authority Malaysia (CAM) and International Air Transport Association (IATA). It is important to have an understanding of the various conditions that may exist. So pilot in the future, they have to make a decision early as the whether or not to take off under existing condition is wise. So that's all from us. Thank you.